Hello and welcome back. So far we have understood how to build a multi-class classification model using 1 versus all or 1 versus 1. Basically, when you use SGD classifier, behind the scenes the scikit-learn is using 1 versus all. So it is like building multiple binary class classifiers and trying to combine the probabilities and trying to find which class the record belongs to. There is another way called a softmax regression classifier which actually does it without doing multiple binary class classifiers. The softmax regression classifier or multinomial logistic regression technique will make multi-class classification without doing multiple binary class classifiers. So how does it do? As first step, the softmax regression classifier chooses k different sets of thetas for k different classes. If the example is our digit recognition ministry data set, there are 10 classes from 0 to 10. So for each class, it's going to take a different set of thetas. Right? If you see gradient descent algorithm, it's going to choose a set of random thetas and then try to adjust them, right? But here in softmax regression classifier, for 10 classes, it will take 10 sets of thetas. So you can think that theta 1, capital theta 1, is a vector of n number of n plus 1 number of thetas, because there are 784 pixels in our data set. It's going to choose 785 random values for class 1, class 0. For class 1 again 785, because 0 theta 0 is also another parameter, right? So it's going to choose for class 1 again 785 thetas. Like that, class 10 785 thetas. So we wrote it in a generic form here, right? K number of classes, k number of large thetas, they are vectors, right? Theta vectors. It is going to choose. The softmax regression classifier is going to choose. And then it is going to find logits for each class. We call that as sk of x. And it is theta transpose x. I hope you remember what is theta transpose x. Theta transpose x calculates the linear combination of all the inputs, of all the x's. It is going to multiply each x with the corresponding theta, right? Theta 0 into x0 plus theta 1 into x1 plus theta 2 into x2 and sums it up. The plus I already used it. So it is going to calculate theta k transpose x. What is theta k here? There are 10 classes. There will be 10 logits for each row. For each row, there will be 10 logits. It is going to calculate. If you have 42,000 records, it is going to calculate 42,000 into 10 number of logits. And then it is going to calculate the exponential value of this logit and normalize it. That is the probability. So if for each row, there are 10 logit values. When you apply exponential value, you are going to get 10 exponential values, e power theta transpose theta 0 transpose x, comma e power theta 1 transpose x, comma e power theta 2 transpose x, like that e power theta 10 transpose 9 transpose x, because there are 10 classes in the ministry data set. So k number of e powers exponential values you get. And to normalize it, what you are doing for the first class, the 0th class, the probability is equal to e power theta 0 transpose x divided by sigma theta e power theta transpose x, theta 1 transpose x plus theta 2 transpose x, like that you are doing. So if you look at this example here, probability for actually 0, 1, 2, like that we have to do for the ministry data set. But here it is theory and we are trying to formulate it. So probability for class 1 is equal to exponential of theta 1 transpose x divided by exponential of theta 1 transpose x plus exponential of theta transpose 2, theta 2 transpose x plus and so on theta k transpose x. And probability for second class is equal to exponential of theta 2 transpose x divided by all the sum of all the other exponentials. Like that, till k we will actually do normalized values. Why are we calculating normalized values? These values are going to be between 0 and 1, the first reason. When you sum up all the probabilities, you will get 1. P1 to Pk, if you sum up, you get 1. Because for each record, there are going to be 10 probabilities. If you sum all the probabilities, you need to get 1. and whichever probability out of those 10 probabilities is high, the record belongs to that particular class. I hope you understood the algorithm, how it works. It chooses random theta sets for k classes and then calculates the logics for 10k different classes. What is logit? Theta transpose x, and then calculate exponential values for all the k classes, and then calculates normalized probability values for each class. Whichever probability is high, the record belongs to that particular class. And when you sum up all these probabilities, you get 1. So that is how the softmax regression classifier works. If we want to look at how can we build a model for softmax regression, the example is here. So I have taken logistic regression, the logistic regression algorithm with multi-class is equal to multinomial. If you say, it is going to work as softmax regression classifier, and solver we are using is LBFGS. It is not gradient descent, and we are using C, a hyperparameter, and max it as 1000, the maximum number of iterations to find out best thetas. Right? It randomly chose theta 1 0 set, theta 2 set, theta 3 set, like theta 9 set, and then it need to adjust those theta sets while iterating through the data or train set. Right? So the C is the hyperparameter. It is like regularization parameter. In our linear regression and logistic regression, the regularization parameter is denoted with lambda. When you increase lambda on a logistic regression, the overfitting reduces. When you decrease lambda, the overfitting increases. But in here, it is opposite to it. In softmax regression classifier, when you increase C, overfitting increases. When you decrease C, the overfitting decreases. We need to understand how to play with these hyperparameters to fix the overfitting problem. So C is the hyperparameter which helps us in reducing fixing overfitting issue. So I have created the class logistic regression and then passed xtrain and ytrain, built a model. Fit is nothing but training the model. Right? After finding all those sets of thetas, I made prediction. I have taken the prediction and then calculated F1 score. I've got 96% accuracy. This is working better than the 1 versus all or 1 versus 1 algorithm. There we have got only 92% accuracy on the train set. But here on the softmax regression classifier, we have got more accuracy, 96%. We are mentioning this softmax regression classifier here because it is the most important algorithm for deep learning. In deep learning, we use softmax or logistic regression as the last node to make predictions on a binary class and multi-class classification problems. You need to understand this and remember it well because we are going to touch upon this again in deep learning. And we need to understand how exactly the thetas are being found or what is the cost function behind softmax regression classifier. So let us meet in another session to understand the cost function, the cross entropy. Thank you.